Hi and welcome to Jim's Radio Shop, where we're working on this Zenith radio, and I'm going to show you a few things that I've noticed. First, the three orange replacement capacitors, and I was focusing in on this rectifier, selenium rectifier, and I noticed, you can see that the top of it there is not connected to anything. Then after shaking away a little bit of this dust, voila, just at the back of that resistor, big resistor is new, the new diode somebody put in. So this is no longer in the circuit. So I don't have to change that out. Now back here is the filter capacitor, and also just in here I removed a capacitor. Here it is here. I removed this capacitor. It was hanging like this. I could see the bottom lead was cut, and I can see this is its replacement. So I was a little annoyed that the last guy had left this in. Some of the repair guys like to do that. So I snipped it out, but when I snipped it out, I was surprised to find there's two wires. Now wait a minute. Capacitors have a wire in either end usually. Well, the third one, well, turns out there's some kind of shielding on there. Very unusual. When I look at the circuit diagram, I'll try to, there, when you look at the circuit diagram, that capacitor is right here. Now you can see it's shown to be in a shielding, grounded shield around that capacitor. Now the replacement is not, well, it's an orange drop. So I doubt that's causing any kind of problem. Just interesting things that I have noticed about the radio. So we're going to have to prove to ourselves that the hum is coming from that capacitor. It's just an insufficient power supply filter, like every radio that's never been serviced that way is in that condition, having a bad filter capacitor. So we're going to end up operating the radio again, and we're going to be putting a capacitor on it temporarily. New parts I just picked up, including a whole bunch of capacitors. These are all 47 microfarad, 160 volt capacitors. Perfect for this kind of radio. The highest B plus in this radio is 130. And that's pretty well below 160. And the capacitor in there, you have to use a magnifying glass to read the schematic. 40, 40, 40. The last one I think is 60. Maybe we can see it right on the can itself. $40, $40, $40, $80. 150, 150, 150. The last 40 is a 25 volt one now. I'm looking for the key that tells me which one's which. There it is. 80 is the half moon. Oh. That's not going to help. Okay, so I can't see the key. The key is hidden by the way the capacitor is installed. So we're going to have to go and use the schematic. Figure out what is what from there. Or we know this. We add 40 to everything. And let's sweat over it. Well, it's 80. It's actually 80, 40, 40, 40. So let's figure out. Let's figure out the 80 one. That's the only one I really have to figure out. So once I have that one figured out, I know all the rest are 40. Man, that's so it's coming right off the rectifier. On the other side of the 22 ohm. I think this says 22. Maybe this guy here. Never mind, these colors look totally different. It's like green, blue, black. Green, blue, black, be like 80, 89 ohms or something like that. I'm never too sure with those particular resistor colors. Changing this rectifier with a more modern type, and it's going to give it a little bit of a higher B+. I doubt we're going to get over 160. Can't see that happening. And let's see if we happen to have a... No, I was going to grab an 80. Let me just check. Just checking for a big capacitor. Okay. Here's what I got. I've got a 68 at 300 volts. So that's pretty well 70. 70 is pretty close to 80. Or I need to put two of these guys together in parallel. That'll give me 90. Well, those are my options here. So let's figure out where the 80 is. 80, as I was saying, right off the top of this. wires are really hard to see. Sometimes the simplest things can become a little difficult here. That's interesting. Okay, so it's a 22 ohm resistor. It's reading 31 ohms. And it's apparently connected